Unfortunately, I made a mistake when I recorded part three, and so I have to re-record it. So you'll actually be able to look at it because I've already written out the answers on the board here. But I will go through and explain where I got the answers and so forth so that you can figure out what I'm talking about. The first one here is number 11. Number 11 states that a rocket sled shown in figure 433 accelerates at a rate of 49 meters per second. Its passenger has a mass of 75 kilograms. Calculate the horizontal component of force the seat exerts against the body. Compare this to his weight as a ratio, and then calculate the magnitude and direction of the total force. And this diagram right here shows you what we're talking about. In other words, here's the horizontal component here. Here's the vertical component, which holds a weight up. And the combination of these two is this force vector right here. So the horizontal component is going to equal ma, where a is the 49 and m is the mass of the individual. So the horizontal component is 3675, which to three significant figures is 3680. The vertical component holds up his weight. It's actually upward directed. His weight is downward directed, so it would be upward directed. And so it's his 75 times the force of gravity, or 735 newtons. Now, if you do this as a ratio over here, you see that the horizontal component is 5 times his weight. So he's essentially has a 5G force horizontally. Now, to calculate this component, you realize that you have used Pythagoras' theorem to do that. F is equal to the square root of the square of the horizontal component and plus the square of the vertical component. If you do the math here, you get 3750. And then also the vertical component represents the side opposite, and the horizontal component represents the side adjacent. So that's the tangent of the angle between the vector and the horizontal. So this is, when you do the math here, it's 11 degrees vertically from the horizontal, or up from the horizon, so to speak. Problem number 22 states the following. Consider a baby being weighed in figure 434. What is the mass of the child and the basket if the scale reads 55? Well, the force is equal to the mass times gravity, so mass will be equal to the force divided by gravity. The force is 55, gravity is 9.8, so the mass of the baby in the basket is 5.6. B basically says, what is the tension between the cord and the ceiling? So between the scale and the ceiling. If you look at the diagram, you're looking at the tension between the scale and the ceiling, which is drawn right here. And you have, it's the same as what the scale measures. And then lastly, what's the tension right here between the scale and the baby? And in order to do that, you have to know that the scale has a mass of 0.5. So it's going to be 55 plus 9.8 times 0.5, which is the mass of the scale. And it's 60. And here are the three drawings here. Number 29 states the following. An 1,100 kilogram car pulls a boat on a trailer. What is the total force resisting the motion of the boat, car, and trailer if the car exerts a force of 1,900 and the acceleration produced is 0.55 meters per second squared? Here's the diagram you need. And the total force of the car is here, and the force working against the car, friction-wise, if we were going to draw a circle, the circle would be around both the car and the boat. And that's important to point out, is it's both the car and the boat. So F net is going to equal the total minus friction. And that means that friction is going to equal F net minus the acceleration that's achieved. And if we do the math here, we have the total force, which was 1900. The mass of the boat and the car is 1800 kilograms. It's accelerated at this rate. If you do the subtraction here, you get 910 newtons for the friction force. Now the hitch, what you're drawing now is a circle around just the boat and the trailer. And so it would be a circle that just takes this into account. So now F net is going to equal the friction force plus whatever acceleration you achieve on the trailer and the boat. And so that's going to equal the 80. It tells you that the friction force of the boat and the trailer is 80% of the total. So 80% times 910 plus 700 kilograms times the acceleration. So the force exerted on this hitch is 1100 newtons in this direction. Number 33 states the following. You have it says, what force is exerted on a tooth if the tension on the wires is 25 newtons and the angle is 15 degrees? So first of all, you have to draw the free body diagram. The free body, I'll draw it over here, looks something like this. The tooth is right here. You've got a wire going this way and a wire going this way. This is 15 degrees here. And so you have tension here and tension here. And so if from that previous problem where we showed the perpendicular force is equal to 2 times t times the sine of theta, you can go back in your homework and look at that. We can use that formula to figure this out. So it's going to be 2 times 25 times the sine of 15 degrees. And if you do the math on that, you get 12.9 newtons. Okay, the last problem we're going to do is problem number 34. Problem number 34 states that a superhero and his trusty sidekick are hanging motionless from a rope. Motionless means that the sum of the forces has to equal 0 because nothing's moving. And it shows you the figure. The superhero's mass is 90 kilos, the trusty sidekick is 55, and the rope mass is negligible. First, draw a free body diagram of the situation with all forces acting on the superhero, the trusty sidekick, and the rope. Okay, so here's the top. So the tension here between the superhero and the ceiling is going to be designated T prime, okay? Then we draw the superhero and designate him B, and his weight is shown here, and then the tension from below him we'll call T, distinguishing it from T prime here, and then that T is equal to the tension that the sidekick's holding on to, and his weight is down here. Now if we consider the superhero alone, we draw a circle here cutting through T prime, and then we consider the trusty sidekick alone, we draw a circle around him, we call that and that goes through T. So if we start with T, we see that T is equal to the weight of the trusty sidekick, or that T minus the weight of the trusty sidekick has to equal 0, or else the trusty sidekick would be moving. We also know that T prime minus T minus the weight of the superhero has to equal 0. There are two downward forces, one upward force. So that means that T prime, if we solve this for T prime, we get T plus the weight of the superhero. If we solve this for T, we get the weight of the trusty sidekick. And we can go ahead and substitute mass times gravity to find the weight of the trusty sidekick, and that will equal 55 times 9.8, or 539 newtons. And that's actually the answer to part C. If we plug that in here, T being equal to that, we can put 539 here, and the weight of the superhero is 90 times 9.8. We add those two together, and that gives us T prime, which is the answer to B, 1,420 newtons. Both of those to three significant figures.